Well, that's no accident here. This is no accident. Namely, what we have here are what we call complementary events. Here's an event, and we're looking at the probability that the event does not happen. And that's actually what they call what the complement of an event is. That's really what we're looking at here. So if E is an event, okay, the complement of that event is that the event E does not happen. The event E does not happen. That's what we have here, right? This was the event that if our event is rolling a 2, we found the probability of not rolling a 2. The probability that we do not roll a 2. The probability that that event rolling a 2 does not happen. So what we had there was complementary events. The notation that the book uses is this. I have like a bar over the what do you call it, the capital letter. That denotes the complement. I mean, another way of saying it is it's everything in the sample space, all the outcomes that are not in the event B. Actually, I think a better way of saying it, it's all the outcomes in the sample space that are not in the event B. And it does turn out, just like we saw over here, you know, if you take the probability of rolling a 2 and add it to the probability of not rolling a 2, that sum is going to be 1. Well, that's no accident. If you take the probability of an event E and add the probability of its complement, that sum has to be 1. That turns out to be true. That sum has to be 1. Okay? Now you might be thinking, okay, well, who cares about that? Well, from here, for one thing, you can easily get the probability of the complement of an event. Right? Just that you find the probability of E, the original event, and do 1 minus it. In other words, if you know the probability of, if you know one of these probabilities, right, somehow you do, you can get the other one easily. And that's actually very useful. That turns out to be very useful. You know, because sometimes one of them is a lot easier to calculate than the other one. I mean, the example we just saw with the die, that one wasn't so terrible. But not every example is as, how do I say it, as nice as the die one. Sometimes, sometimes finding the probability of a complement of an event E, finding the probability of the complement of E, sometimes that's easier than finding the probability of E. And the other way around. And again, by this formula, if you know one of those, you can easily get the other one. You just subtract it from 1. All right, so here's an example I want everyone to try now. We'll take about, I guess, let me pause the video. Take about 3 or 4 minutes. Take about 4 minutes, okay?